Hi everyone, so welcome back to my session. This is going to be a new course, you can say, a new topic in engineering mathematics. Okay, so this is going to be highly demanding topic, right? We call it probability and statistics. So before I introduce what is probability and statistics, okay, first of all, let us have a glance at official GATE syllabus, right? Because this is a topic where many student fail to understand properly. Okay, so what is my idea why I'm conducting this course is because this plays an important role in your technical subject as well. Like if you want to understand, if you're from electronics and communication and you want to understand communication system well, so you need to have the concept of probability in statistics. Okay, and in future if you are going to learn machine learning or AI, or you can say you are going to write gate in data science, right? So data science and AI, right? So this probability and statistics is going to play an important role. So let us have a look here. And in the gate examination also question will be asked. So this is a syllabus, okay, for gate ECE, right? For gate ECE, so you can see here probability and statistics. So they have started with the measure of central tendencies like mean, median, mode, okay, standard deviation, and combinatorial probability, okay, probability distributions, okay, and binomial distribution, Poisson distribution, okay, exponential. So there are different types of distribution mentioned in the syllabus, right? There are different types of distribution mentioned in the syllabus. So initially they started with the statistics, that is mean, median, mode, okay, like they are also known as central tendencies, right? So central tendencies, so mean, median, mode, central, and the standard deviation and combinatorial probability distributions. So there are different types of distribution, right? You know, we will talk about probability distribution, binomial distribution, Poisson distribution, right? So why we are going switching from one distribution to other, right? Why do we need Poisson distribution, so on and so forth? We will see in this session, right? Because nowadays what happens in the gate examination, they ask application based questions as well, right? So this is exponential distribution and the normal distribution. This is very important, okay, for electronics people. And joint and conditional probability we will see. Okay, so this is, you see, the as far as this syllabus is concerned, this syllabus is very precise and concise. It's a very small syllabus, right? So before I will begin probability and statistics, uh, I'll introduce one of the very important topic that is known as permutation and combination, right? PNC, right? PNC, because you should understand the principle of counting, right? Principle of counting, okay? It is very important topic, the principle of counting, okay? Why do we need counting? Based on this counting, you can solve probability question very quickly, right? So any syllabus you see, PNC is not mentioned here, right? But PNC can help you understand, can help you solve question from the aptitude as well. Okay, because one question they might ask from PNC in aptitude, or you might say if you're good at PNC, okay, so you can solve question based on probability, right? So basic probability I will discuss, okay. I will not directly jump to random variables, okay, and I will not directly jump to distributions and densities, right? Okay, fine. So we'll talk about random variables. That is one of the very important topic. So you can expect from here around 2 mark or 4 mark questions. I mean, in the gate examination, right? So 2 to 4 marks, okay, 2 to 4 marks is the weightage. Like linear algebra has 4 marks. Certainly, you will get 4 mark question. From here also you can expect 4 marks. Okay, but huge application is there, right? Like in communication system, right? Communication system. Okay, you should be good at probability and statistics, right? Yeah. So this is a gate syllabus for instrumentation engineering, right? Instrumentation. Okay. So what is this syllabus they have mentioned? You see, for electronics, they started with mean median mode, right? But in this case, you see they have started with the sampling theorem, okay, conditional probabilities, right? Okay, so we will see all these concepts like conditional probabilities and all with the help of one tool. Okay, in future I will introduce what is that tool, right? So that tool will be known as tree diagram, right? Tree diagram. Okay, so if you are able to draw the tree diagram, right? If you are able to draw the tree diagram, and if you understand the divide and conquer rule, what is the meaning of divide and conquer rule? See, any question based on probability you can solve. Only two things you need. The very first tool is you should know divide and conquer rule. Okay, divide and conquer. Divide and conquer rule, right? What is the meaning of divide and conquer rule? Suppose you have a very big problem. You have a very big problem. Okay, if you are able to divide that very big problem into smaller problems, right? Okay, so you start solving one problem at a time. Okay, so what you can do here is a big problem can be divided into different stages, right? What we can say here is that suppose this is a problem, right? Okay, so further you can divide these problems into smaller pieces, okay, like this in different stages, right? So you can say this is stage number 1, stage number 2, okay, stage number 3, and so on and so forth, right? Okay, so you can solve any question then, right? So whenever probability questions are given or any kind of questions from any subject you take, right, what you do always is divide the problem into different stages, right? The stage number 1 is, okay, information is given, you have to understand the information. The second stage should be what concept you are going to apply, to use that data which is given in the question, right? And then what you do, and then you plug all the information and you can get the answer, right? So always keep in mind divide and conquer is one of the very important mechanism, okay, to deal with any kind of situation. So this is one of the motivation for me, okay, whenever I see my life. Okay, yes, Raviteja, hi, good evening. Yes, okay, so whenever I see any problem in my life, right, so I always go for divide and conquer, right? So I don't want to achieve anything in one go, right? So stage 1, stage 2, stage 3, right? So you divide each problem, a bigger problem into smaller stages, and then try to understand, okay, try to handle, and then you can combine. Okay, fine. So you will get kind of a tree diagram. Okay, you will get kind of a tree diagram here, right? So tree diagram is one of the important tool, okay, to deal with any sort of probability concept, right? The basic probability, you can say. The sampling theorem and the conditional probability, again there is a measure of central tendencies like mean, median, mode. Okay, what is the relation between mean, median, mode? What is mean, what is median, what is mode, right? And what is the meaning of standard deviations? We will also see the physical significance of these words, right? Mean, median, mode, standard deviations, variance. Okay, why do we need variance? Okay, if you understand these concepts and if you understand their physical significance, right? So while dealing communication system and all, you will be able to understand, okay, here variance concept is gonna be used, right? Okay, so variance is always computed around the mean. You have to always keep in mind there will be a mean and you have to compute the variance around the mean, right? Okay, so we will discuss the physical concept as well, physical significance, and this is very important here, random variable, right? Okay, and random variable you will be having different kind of like discrete random variable, continuous random variable based on sample space, right? So you will be having two kind of sample space, discrete sample space as well as continuous sample space. So accordingly you can define random variables. So we will see how to understand, how to define this word random variable. Okay, random variable will be of like you can say discrete and continuous random variables. Why do we call it discrete and continuous random variable? You will be having a sample space. We will see what is the meaning of sample space and all. Okay. So and then if you have okay, these normal Poissons and binomial distributions, right? So the syllabus is quite small here, right? You can see. So in EC there was no sampling theorem and all, but here, so we'll cover everything, right? Yeah. So keep in mind this tree diagram. If you know the tree diagram, okay, See, in these syllabus, they haven't mentioned, base theorems, right? They haven't mentioned anything, right? They have directly written these distributions and all, right? But we need to understand the base theorem. We need to understand the total probability theorem, okay? Those topics are important, okay? Fine. And this is a syllabus for GATE electrical engineering, right? GATE electrical engineering, okay, where sampling theorem, conditional probabilities, right? Mean, median, mode, standard deviation, random variable, okay, and normal distribution binomial. And they have added some new topic here again, right? Like correlation analysis and regression analysis, right? So as you can see, if you combine all three branches, electrical engineering, electronics engineering, as well as instrumentation, so you have to cover everything, right? Uh, Let us jump to directly the data science and AI. So this is a new syllabus for GATE, data science, right? Data science, SCIENCE, data science and AI. So if you want to become good in probability and statistics, so please follow this, right? It is a complete syllabus they have given, and this is the sequence. This is going to be my overflow, okay? I mean, not overflow, you can say my lecture flow is going to be, right? You see the syllabus, and this is my lecture flow actually. Whenever I teach probability and statistics, so I start with the counting principle, right? How to count the things. Why do we need counting, right? So counting includes permutation and combinations. Then we'll start with the probability definitions. We'll talk about probability axioms, right? The sample space, see, they have given direct syllabus, right? EC, electrical instrumentation, they are just direct syllabus, but they are not, but we need to talk about what is the meaning of sample space, what is the meaning of event, right? Because after all, we will compute the probability of the events, right? We are going to compute the probability of the events, okay? We are not going to compute the probability of a sample space, keep in mind, right? Because sample space will combine all sort of outcomes, right? So if you are going to compute the probability of sample space, that will be 1, right? So what we are going to do here is we will be computing the probability of what? The events occurring in the sample space, that you have to understand, right? So we need to understand what type of sample space are there, uh, what type of events are there, how many kinds of events are there, independent events kya hota hai, mutually exclusive events, right? Marginal, conditional and joint probabilities. You see, they have mentioned everything, like base theorems, right? The conditional expectation and the variance, right? And the mean, median, mode, standard deviations, correlation and covariance, random variables, okay? So their physical significance also we have to take a look, right? Physical significance, okay? See, physical significance we will see, okay, with our real world problems, right? So how this probability is important for you, right? Yeah, one of the very important reason is if you're going for electronics paper, so you should be good at probability and statistics, let me tell you. Then only you can become a topper in the GATE, right? And you can achieve below 10 rank, right? So probability and statistics plays an important role. It will help you in communication system, as well as you can gain good marks in aptitude, as well as in probability questions, right? Fine. So physical significance of a random variable distribution, all those things we will see. So this is a complete syllabus, okay? Continuous random variable, probability distribution function. What is this probability distribution function, right? It is not a density function, guys. It is a probability distribution function, which tells you the probability only, right? Okay, probability. And we'll talk about uniform density function, exponentials, Poissons, and normal, standard normal, and T distribution, right? Chi-square distribution, cumulative distribution function, we call it CDF, right? CDF, okay? Conditional PDF, central limit theorem. This is important. Central limit theorem, confidence interval. There are different tests actually we are going to see, right? Jet test, T test, and chi-square test, okay? So these are the important tests. So if you are able to complete this syllabus, I'm not going to follow any other syllabus. I will follow this syllabus, okay? That is data science and AI syllabus, which is a complete syllabus for probability and statistics, right? And the book you guys can follow for this, one of the very popular book is known as Populi. Populis, right? Populis is one of the good book, right, for probability and statistics, right? So you guys can follow, and this will help you also in okay. And some other book is there. One of the book written by one of the professor, that is MIT professor. So his name I will reveal later of the once the probability will be started, right? So one of the professor has written the book. Okay, his book is also available on Google, right? So you guys can follow. Okay, that this entire syllabus you can find in that book. Okay, and the very good language and the examples. Okay. My main support is gonna be what? If you attend my sessions, you will be able to solve any kind of questions, right? Fine. So mainly what I'm gonna do here is I will start with the counting concept, right? So the pre-counting, okay? Why do we need counting? Because the very first topic that I will be discussing is the you know permutation and combination. So my lecture flow will be this. My lecture flow will be, first I will talk about P and C, and second I will talk about basics of probability. Okay, probability, right? Okay, because random variable and random process, that is very simple. Okay, the random variable is very easy, right? But basics are, we are lagging in basics. I am pretty sure everybody is lagging in basics, right? Because they forget in their school days, or mastery is not there. You need to have the command on this, right? So basics of probability, and statistics. Basics of probability we'll cover first, right? And then we'll move to random variable, and then we'll see for random variable different types of distribution, density functions, and so on and so forth, right? Fine. So the counting is one of the very important technique. Counting. Okay, why do we need counting? What is this counting, and so on and so forth? That you should know first, right? Okay. So it is one of the important concept that you have to understand, right? Fine. So first is counting, okay? And here in this counting, basically, can somebody tell me what is the need of counting? Why do we need counting, right? So P and C, under this topic, we will see P and C, and based on counting concept, we are going to answer the question, right? So uh, P and C is all about counting, right? So if I am going to talk about permutation and combination, right? So counting plays an important role, right? But before that, before starting with the permutation and combination, you need to understand what is this counting, right? Okay. And also you can say that you can say that what is the meaning of factorial, because after all we are going to deal with the factorial, factorial. So what is the meaning of factorial? What is the concept of factorial? Why we need factorial and all? That is also one of the very important concept that you should know, right? I think everybody might be familiar with the factorial. Okay. So we'll start with the concept. Okay. So you can say that we can take some of the examples. Okay. So I'm just going to take some of the examples. Okay. So you can take one A4 sheet. Okay. What you can do? What you take A4 sheet paper, right? Just take A4 sheet paper, right? This is a A4 sheet paper, and start start folding it, right? Okay, you can fold it from both sides. Okay, and see how many times you're going to fold it, right? So what question you're going to ask here is how many times, right? How many times you can fold this paper, right? How many times you can fold this paper? So you take A4 sheet. Okay, you're going to take A4 sheet paper, right? You fold it one time, again you fold it second time, again you fold it third time, again you fold it five times. Okay, so I think if I ask you to fold it for 40 times, so it will not be possible. Okay, it will not be possible to fold it 40 times, right? You can only fold it maximally, you can say, for five times, because as you are folding it, that paper is becoming thicker and thicker and thicker, right? So you know after folding, your paper becomes thicker, right? So at the time will come, you will not be able to fold it, right? So my question is how many times you can fold it. Okay, this is the meaning of counting, right? Suppose you have got one problem, okay, that is called a rubric cube problem, right? I think everybody might have. So this is nothing but a paper folding example. The example you can give is paper folding example, right? Paper folding example. Okay, and the second example you can have is the rubric, you know, Rubik's, Rubik's cube example. Okay, Rubik's cube example, right? So suppose you have got one Rubik cube. Okay, so how many ways are there? You can make the color same in all those faces, right? So I think everybody might have played with the Rubik. Okay, so in this case also you need to do all sort of combination, right? After all, you're playing with the competition and combination, right? You're arranging different sort of a cube, right? So I mean colors, right? So suppose you have got a 2 by 2 by 2 Rubik cube, right? You can also have 3 by 3 by 3 cube. So how many ways are there? How many ways are there that you can you can understood? So this is very important to understand, right? So what are the total possible total number of possibility if you have the Rubik cube example, right? So my question will be what are the total number of possibilities? Okay. So these are the questions that you can ask by yourself, right? How many times you can fold it, right? How many is one of the very important, statement of any question you will find it, based on counting, right? Based on, you can say permutation and combination. So we'll see what is the meaning of permutation, what is the meaning of combination, right? But wait for that. So if you have a Rubik cube, okay, like you can say you have a Rubik cube of 2 by 2 by 2, okay. So you can have Rubik cube of 2 by 2 by 2, 3 by 3 by 3, and so on. You can have 8 by 8 by 8. So my question is how many total possibilities are there? How many, you can say what are the total number of possibilities, okay, are there? Okay, how many ways are there? You can get the similar patterns, right? Okay, all colors should be same on the same face, right? So that is very important to understand, and it is very, it is very complicated as well, right? So how many ways are there? You can switch, okay, the color combinations, right? And if you have got these like 2 by 2 by 2 cube, or if you have got 8 by 8 by 8 cubes, it's a very complicated process, right? Understand? So so number you will get is like if somebody will ask you, suppose you have got, just I'm going to highlight some number, okay, don't get worried about these numbers, right? I'm just going to write all the possibilities, okay. I hope this makes sense, the sign of what I'm going to talk about, right? So suppose you have got 2 by 2 Rubik example. So the total number of combination you can say is around 36 7 4 160 combinations, right? Okay, so nearly it is 36 lakh, nearly it is 36 lakh, you can see. Okay, so as 3 by 3 by 3 Rubik cube example is there, right? So what you can say, understand, so it will go on, right? It will become 43 lakh, okay, and then it has so many examples, right? So you keep on increasing, okay, so many combination is going to happen, right? So understood. So please remember these things. So you see these numbers are increasing, okay, so for this numbers will go on, okay. So total number of possibilities we cannot compute. Okay, understood. So playing with the Rubik cube is fine, but if somebody is gonna ask total number of possibilities, how many ways are there you can rotate? Okay, you can switch the color combinations, right? So it is going to be very difficult, right? Understand? But what I'm going to talk about is the this is very important. So these numbers we cannot write. I mean, we cannot compute like this. These are very big numbers, right? So if I ask you that, okay, remember one of the very good example that I'm gonna give you now, right? Wait, I'm going to give you, okay. So suppose you have got two friends, right? Okay, I'm just going to give you one very important example, right? Suppose you have got two friends, okay, like one friend is here, you can say it is Ravi, okay, you can say, and this is second friend, you can say it is a Pransu. Okay, these two friends are there, Ravi and Pransu, right? They are from my classroom, you can say, right? So suppose they decided to take selfie, right? Ravi bought one 15 Pro Max, right? And they have decided to take selfie, right? So my question is, in how many ways, these two, okay, friends take their self pictures, right? Okay. Suppose somebody is there who is capturing their picture, right, with the new you can say new 15 Pro Max. So Ravi and Pransus are there, they are excited about giving their self photos, right? So the question is, in how many ways, right? What is the question? In how many ways, okay, in how many ways can two friends, okay, take their picture, right? This is my question, right? So I think anybody can tell. Okay, so can you answer the question in the chat box? You guys can also tell me. Suppose there are two friends, right? So one way is what? Ravi is standing left side, okay, and okay, and the Pransu is right, okay. So you have taken one combination, right? You have taken one picture. Now they are swapping their position, right? So Ravi is here, now Pransu is here, right? So how many combinations are possible? Okay, so in how many ways these two friends, okay, can take their selfie, can take their picture, right? So uh, I think anybody can answer this, right? So if they're, you know, this is the first, okay, the first combination is this. Now what you can do is you can swap the position, right? Okay, so this is the, you can say, one way, and second way will be here the Pransu is going to be here, okay, and you can say the Ravi is gonna be here. Okay, so these are the two combination that you can get. Am I correct or not? So they go. You need to realize, you need to feel in your real life, everywhere you all time do kind of permutation and combinations, right? I mean, you do this kind of situations, but you never count, okay? You never count, right? So we always take selfie, we always take photos, right? So what are the ways that you can take photos and all, right? So these are the things. So how many ways are there that you can talk about, right? So there is only two ways, right? How many? The answer is what? Only two ways. Two friends are there, two ways, okay? One way is that, one way is by swapping the position. Now let us go for three friends. Let us go for three friends, right? So example number next. Suppose there are three friends, okay? Okay, okay, let me, okay. Nowadays, you can see, okay. So let me take this guy is Ravi, this is Pransu, and you can say this is Himanshu, right? Okay, Himanshu, okay. So Ravi, Pransu, and Himanshu, these three friends are there, okay. They decided to, they met each other one day after getting good rank in gate examination, and they decided to take selfie, or they decided to have a picture, right? So how many ways are there they can take pictures? Okay, that is a question, right? In how many ways? Let me copy that question here as well. The same question I'm going to copy, right? अब देखो आपको काउंट करना है, right? You have to count it. This is a principle of counting, guys. This is a principle of counting. You can say question, you can put here itself, or let me put here, right? The question I have kept here, no problem. Yeah. So I hope this makes sense to all, right? So I don't have actual picture. I'm just going to put here, right? So three people are there, okay? Ravi, Pransu, and Himanshu. In how many ways can these friends, okay, can these three friends, you can say, three friends take their picture, right? So first way is that, okay, the way they are standing, okay, the way they are standing, okay. Now they will swap the position, okay. And Ravi will say, no, first I will take picture with Himanshu, right? Pransu will say, okay, you can take it. You just come to mid, okay. Okay, so these three guys can switch, right? So what are the possibilities, right? What are the possibility, okay, that they can take picture, right? So now again, if you go for swapping and all, it will take a lot of time. Okay, how many times you will swap people and then take pictures, right? I'm just going to ask you that how many ways are there these three friends can take picture, right? So you can just tell the number of ways, okay? Needless to needless to swap your position again, and then because it will waste your time, right? Okay. Suppose practically you want to count, right? Practically I'm telling, right? So what will happen? Three friends are there. One friend is standing here, one friend is standing here, one friend is standing here, right? So three friends are there, right? One way is done. Next, now Ravi is coming in the middle, right? Himanshu is going next. Pransu is there, right? So one ways, right? So in this way, you will, you will take pictures, click, okay, click, 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 click. So how many ways are there, right? So it takes time, right? If you are in the ground and you're going to count in this manner, so better what you can do is you can say that there are three friends, right? So the answer for this will be 3 into 2 into 1, right? 3 into 2 into 1, which is 6 ways, okay, which is 6 ways, guys. Okay, so here I am using one very important concept, okay. We call it factorial. क्या बोलते हैं उसको? Factorial. You know, computer does not know factorial here, right? We must understand what is the meaning of factorial, right? You see, there are three friends. If someone is going to ask you in how many ways three friends can take pictures, okay, okay. So because in convocation, in farewell and all, we always take pictures and all, right? So you should understand these things. There also you do a lot of combination and permutation. No, my friend will be standing with me, or kind of, yeah. So in how many ways these three friends can take pictures? Okay, so if number of people, okay, if number of people are increasing, right? Okay, so let us take 5 people are standing, okay. So if there are 5 friends, right? So how many ways they can take picture, right? So you can say that example. Okay, suppose there are 5 friends, 1, 2, 3, 4, 5, and the question is in how many ways these 5 friends can their picture, right? So what will be the answer? Okay, what will be the answer? Will you do like you will swap this position and you will try to take the picture, one picture, second picture, third picture, fourth picture? Oh my god, it is going to be a cumbersome process, right? So you should know the concept, you should recall the mathematics, guys. Okay, that is why I always suggest don't leave mathematics. That is gonna make your life easier. आपको पता नहीं है, I will tell you my story in future. Right now I don't have any story, right? Okay, but in future if I would be having any sort of story, I will reveal it. Okay, so mathematics plays an important role. How can you transition from a slum place, right, a place where you are facing a lot of challenges, if you are good in math? You see here, so you always excited about taking pictures and all, but you don't know how many ways you can take pictures, right? What is that concept called, right? So in how many ways 5 people can take pictures? So you will answer that, yeah, 5 into 4 into 3 into 2, 1. It's a very big number. 5 into 4 is 20, 20 into 3 is 60, 60 into 2 is 120, right? It's a very big number, right? It turns out to be, 120 ways are there, right? 120 ways are there, right? So one person can take pictures is one way, two-person can take, remember. So one person, one ways, right? Two-person, two ways, right? Or you can say 2 into 1, right? Three-person, okay. How many ways? 6 ways. What is this? 3 into 2 into 1, right? Four-person, how many ways? 4 into 3 into 2 into 1, right? So 4 into 3 is, it is 12, and this is 24, right? Ways. You are just multiplying by 4. Okay. So I think this is clear for all, right? I think this is clear for all. So this is nothing but the examples of factorials, right? You can say these are the examples of factorials. Okay. Okay. Number of ways you are taking picture, you are capturing picture, right? So this is nothing but the example of, you can say, factorial, right? Understood? So it is going to be very big. Okay, it is going to be very big. Remember. Okay. Understand? So this number is gonna be very very big. You can say 5, so it will correspond to 120, and then if you take 10, right? So this number is gonna be very big. You can say 3, 6, 2, 8. Needless to count in the head, guys. Please, okay, please, okay. What you can do, just write the number 3628, 800, right? Understand? So it is a horrible number. It looks very big. Okay. Suppose there are 10 friends. So there are how many ways are there? How many possibilities are there? They can take picture, right? So you see how many pictures are there. Photographer will loot you. Okay, you will be having a crunch of money here, right? So what is this? You can say 36,28,800, right? It's a very big number. So mobile will also will not be able to store these number of pictures. Okay. So we are happy with one picture itself, because after all, the number of people are same in the frame that everybody knows, right? So what is the need of taking different sorts by swapping people, right? But I wanted to explain you the factorial, okay, the word factorial. Okay, the word factorial, factorial. These are the examples of factorial, you can say. Okay? These are the examples of factorial, right? So please remember this, okay? So So you have to be very careful about the number of objects in the system, right? How many objects are there, right? So we need to be careful about number of objects in the system. Okay. Number of objects in the system, right? You see, if there are 4 objects, so these many possibilities. 5, 120, 10, gone, right? Gone, right? How many objects are there? The difficulty level gets, keep on increasing, right? So you have to understand this. Okay? This is very important to keep in mind, right? Okay. So I hope this makes sense to all, right? This is important, and so the factorial is denoted by capital N, right? Capital N, okay? And it is written by, it is n, n minus 1, n minus 2, and so on till 1, right? This is the factorial, and I have given you the factorial examples. ठीक है, आपको समझना है in PNC, factorial plays an important role, right? Factorial is going to play an important role, right? So this is going to be very important, right? One more question I will ask here is, right? Suppose we have got, after all, we are learning how to count, right? What is that? How to count. So first counting we have done, Rubik example we have seen, the paper folding example we have seen, right? And if you keep on folding, fold it, again fold it, okay, again fold it, you take A4 sheet, fold it, again fold it, again fold it. So it will become, kind of, it will become thicker, the time will come, you will not be able to fold it, right? Okay. Understood. That is very important to understand. Okay, so if you see the number of ways you can fold it is enormous. Okay, it's a very big number, right? That number is like, the distance between, you can say, the moon and the earth. Okay, that is the distance that you can cover, right? So this is very powerful idea. Okay, so if we have got this kind of a situation, suppose we have got two axes here, right? One axis is x and one axis is y, right? X and y, right? X and y are there, right? So you can say that this is 0, this is 0, right? And you can draw these lines 1 2 3 4 5, 1 2 3 4 5, right? You can say that this point is there, which is 5 comma 5, right? So you have to reach here, you have to reach here. So what are the total number of ways? You have to start from your journey from 0 0 and you have to reach here, right? Please remember. So you can say if you're going this in this direction, so we call it up, and if you're moving in this direction, we call it right. Okay, so the question is what? Question is what are the total number of ways? What are the total number of ways? Okay, you see this example, okay, keep in mind this, okay, x and y, and the point you are starting from 0 0 and you have to reach 5 5, right? So what are the answer, right? So what are the total number of ways, right? So okay, if you're starting from 0 0, right? So yes, so what you have to count here is you have to count, suppose see, if you go like this, you can't go see, you have to go like this, okay, you have to go like this, you have to go like this, okay, go like this, go like this, okay, like you have to move right then up, right then up, okay. So what are the number of ways that you have to compute? Okay, it is a very good question, right? Move like this, okay, move like this, move like this, okay, move like this. You're moving one at a time, right? Right then up, right up, okay. You can also move two, okay, then you can go up, right? Okay, then you can go one time, okay, and like this. So there are various ways are there, right? There are various possibilities, right? Okay, so which one is the valid possibility that you have to understand, right? Okay, so please remember this question. So you guys can try and let me know the answer, right? What you think exactly for this, okay? I will solve this question later, right? So okay, so you can say this is just like a homework, okay? You have to go from here to here, and what are the total number of ways that you have to obtain, right? So understand. Fine. So this is very important, okay? So as I told you that, guys, how many, okay, how many is one of the important keyword that you have to keep in mind. So I have given you some practical examples here, right? Like what real life examples. But what kind of question we can expect in the examination, in aptitude as well as in the gate examination is, suppose you have got some digits, right? Like we have got the digit from 0 to 9, okay? So if you have to form a number, right? So we need a digit, okay? We need a digit, right? Suppose you have to form a 3-digit number, so you need digit, and from here you will get digit. You have digit from 0 to 9, right? So if you go for decimal system, so the question is how many. No, this is a keyword, please remember, how many. These questions you can do without the help of, you know, with the help of counting only, right? So we are just discussing counting, okay? So the question is how many 3-digit numbers can be formed? How many 3-digit number can be formed? How many 3-digit number can be formed using 1, 2 and 3, right? And the condition they have mentioned here is without repetition, right? You don't have to repeat, okay, without repetition. Okay, without repetition. So this is a question that you have to answer. What is this question, guys? How many 3-digit in can be formed using 1, 2, right? Okay. So if you're going to write, you can consider this is like a 3 friends are there, right? 1, 2, 3, and then you are swapping, okay? So the question is how many ways are there, right? Okay. So you can solve this kind of a question by using the concept called filling the space, right? You can say filling the space. Filling the space. Okay. Please remember this is a concept called filling the space, okay? So you have got 3-digit, you have to get 3-digit number. So you have got 3 places, right? One place, you can say this is first place, this is second place, right? 1, 2, 3. These are the 3 places where you have to put number, okay, digits, okay, so that you can get a 3-digit number. And you have got 3-digit 1, 2, 3, right? And you have to. So how many ways are there? The first position can be filled using these 3 digits. You can say there are 3 ways, okay? There are 3 ways, right? You can say you can say this space can be filled, right? The first, you can say first space, okay, can be filled. Now go to second, right? Now you can say one of the digit you have already used, so you can't use again that digit, right? So how many digits are left? You have got 2 digits, okay, only. So how many ways are there that you can fill this guy? So you can say 2. And how many ways are there you can fill this, right? So you can say 1, because only 1 digit you will be left with. So you can multiply here, right? So there is a choice 3 into 2 into 1, which is nothing but what this is nothing but 6, okay? Or you can say 3 factorial, okay? 3 factorial, right? So question was what? How many 3 digits a number can be formed using 1, 2, 3? So what is the concept that I'm using is filling the space concept. Okay, you have 3 digits, right? The first space, the first place that you can fill with the digit is what? You can say this is a 100 place, right? 100, then 10, then unit digit or unit place, okay? So you have got 3 digits, right? 1, 2, 3. So you can fill here in 3 ways, right? And second one is what? The first, okay, you can fill here. Either you can fill anything. 1 digit already has been used. Suppose there is no restriction of this kind, like there is, without repetition is not given, right? So the same question you can take, okay, the same question, and there is no restriction, right? There is no restriction. There is no restriction at all. These are the basic questions that I'm telling you, right? How many 3 digits number can be formed using 1, 2, 3? Okay, using 1, 2, 3, you can say. So what will be the answer here? See, you have got the spaces, 3 spaces are there because you have to get 3-digit number. 3-digit number means what? There will be 3 space, right? And you have to fill these 3 space, okay? So first space can be filled in how many ways? You can say 3 ways. Second space can be filled with how many ways? You know that because already you have again 3 digits which are available, okay? You can put here, right? So you can say that it is also going to be 3. It is also going to be 3 into 3 into 3, which is 27, right? So you can say that 1, 2, 3, 2, 1, 3, okay? So many ways are there, right? You can switch 1 2 3, in either combination, right? So I hope this makes sense, right? So if this kind of number, if repetitions are allowed, right, this will be the answer. If repetition is allowed, if repetition is allowed, then answer will be this, right? Please remember that. Suppose you have got 4-digit number, right? Let me take the second question. Okay, this is the question number second only. Okay. Suppose how many 4-digit number, you can say how many 4-digit, let me erase here. This is 4-digit number can be formed using 1 2 3 4, right? 1 2 3 and 4. Okay, without repetition and with repetition. Without repetition and with repetition, right? So please remember this. Okay, question number third. So can you answer here? So you have to use the concept called filling the space. Okay, filling the space is very important, and these digits you have to use. Okay, 1 2 3 4 is given, so it's a good thing, right? So what you can do here is already they have given you the digits. Okay, there are 4 digits they have mentioned. Suppose they haven't mentioned any digit, right? So you have got, 10 digits, right? 0 to 9, there are 10 digits, right? So we'll see that kind of a question also. Okay, so how many 4 digits? So you have to use the concept of filling the space. So you need to have 4 spaces to be filled with the digit 1 2 3 4, right? This thousand, hundred, tens and unit place, right? So you can fill it by 4 digit and then multiply 3 2 into 1. That is nothing but 4 factorial, right? Okay, 4 factorial, you can say this is 24. 24 ways are there, right? You can have the combination, right? How many 4-digit number can be formed? So 24, right? But suppose there is a repetition allowed, so answer will be what? 4 into 4 into 4 into 4, which is 4 to the power 4, right? Understand? When repetition is allowed, okay? When repetition is allowed. Okay, please remember this, okay? The way I'm telling you. Okay. So guys, with this I will wind up the session. I have to take more sessions. This was just an introduction, so you have to let me know how this session is for you, whether it is meaningful or not. Then we will start discussing more principles. We have started with the principle of counting. We have to discuss some of the important principles like addition rule, multiplication principles, when you can add possibilities, when you can multiply possibilities, and so on and so forth. And we will do many problems, right? We are going to talk about we will solve many problems, right? In fact, I will also discuss one of the very important problem. We call it Monty Hall problem, right? So you guys can search also one of the very popular problem in probability, Monty Hall, right? Monty Hall problem. Okay, I will discuss this problem also for you all, right? Okay. So with this, again I will discuss. Okay, so initially I am going to focus on PNC, and I will make you strong in PNC. Then we'll go to probability. Then we will start our easy topic. They are random variable and random process. If we are from electronics and communications, so random variable is one of the very easiest topic for us, right? So let us make the basics strong first. Okay, up to advanced level, you can say. We'll meet in the next session. Thank you so much. Take care all, right?